at the beginning of three-day lecture, I will give an introduction. My name is Tetsuya Uchimoto from Institute of Food Science, Tohoku University. And also, I'm a member of joint laboratory between Tohoku University and University of Lyon and CNRS, Elite Max. Okay, so as an introduction, I want to explain what is maintenance. And also, I'll explain a guideline of this course, three-day course. So what you see here, these are all serious accident. I pick up 3 accident. Okay, so this is a high-speed train accident in Germany. Many passengers were killed, and the cause of this accident was fatigue in the shaft of the train. And also, this is a river bridge collapse in the United States, and the cause is a corrosion of the support of the bridge. And countermeasure for the corrosion was not sufficient. So that's why a lot of people were killed. So this accident was occurred in a nuclear power station in Mihama, Japan, and cause is corrosion of a pipe. And due to the decrease of pipe wall, a serious pipe rupture occurred, and some were killed. So in order to avoid this kind of tragedy, so what we should do? So this is a maintenance, and all these things, the train, bridge, or plant, these are artifacts that is made by human and made for human being. We call artifact. And in order to avoid the accident of artifact, we should do maintenance appropriately. And looking at the lifetime of artifact, it starts from design, publication, and operation. Finally, decommissioning to end the service. This is a life cycle. And in order to avoid accident or we should do maintenance activity appropriately. And the maintenance activity, what is maintenance activity? So it includes some activity. So at first, we should see if something happened to artifacts. So we should do inspection. And sometimes we will do non-destructive testing. Later, Professor Guy Fiat will give a non-destructive testing. And after we check the condition of a component in artifacts, if there is nothing, so it is safe, no problem. But if we found something, so we need an evaluation to judge this is okay or not, if this is acceptable or not. So this evaluation should be done based on material science, especially degradation science. And in view of degradation science, if the target is safe, we continue to use. Under degradation science, Professor Nicola Mari will give a lecture today, just after this introduction. And if the target is not acceptable, so we need a countermeasure like repairing or replacement. Okay, this is a cycle of maintenance activity. But this cycle starts from inspection to replacing. If it doesn't work well, so sometimes we had a serious accident. So these are the example of accident occurred in nuclear power station that is required, that high reliability and high safety are required. Okay, this is not an accident, but almost a serious accident occurred in Davis-Besse nuclear power plant in United States. And this is a pressure vessel, and this is a very important boundary to contain radioactive material. And the wall of the pressure vessel was a significant degradation by corrosion was found before that penetration. As you can see here, the wall was corroded seriously. The other example is a pipe rupture occurred at the Mihama nuclear power station, and due to the corrosion, the pipe rupture was occurred, and unfortunately, some were killed by this accident. So in order to avoid this kind of accident, we need to optimize the maintenance activity that is consist of inspection or monitoring to see if the target is in good condition or not. And also, we need a good evaluation to make an interpretation of results of inspection. Then depending on the evaluation, we can discuss the coping with the sequence. So we can judge if we can continue to use or repair or replace the component. So in order to avoid serious accident, we need an optimization of this activity. So in this lecture, we will give how to optimize or how to optimize this activity. We will give a lecture for giving a lecture for inspection or evaluation based on the material science. Okay, so this is a lecture plan. So at the beginning, we will give an introduction of each component of maintenance activity. So this, now I'm giving an introduction of risk-based inspection. After that, Professor Nicola Mari will give an introduction of damage and degradation to be evaluated in maintenance based on material science. After that, Professor period from inside central Iowa will give an introduction of ultrasonic characterization of material as a representative inspection method of inspection method. And Professor Egi Fiat will 3 more lecture for you to understand the fundamental of ultrasonic testing and application of ultrasonic testing. And this afternoon, Professor Sylvan Danset from Elite Max will give an introduction of to a fracture and a fatigue behavior of material. And also Nicolas Murray, Professor Nicolas Murray, again, he will give a lecture on the study of corrosion on basic aspect. Then for students who join the intensive course of Tohoku University, we will do a project work after the seminar. Okay, and tomorrow at the beginning, Professor Gael Sebald will give a lecture on fundamental electromagnetic non-destructive testing. That is another representative non-destructive testing inspection method. And also from me, I'll give application of non-destructive testing. Then again, Professor Guy Fiat, he will give a lecture on fundamental of ultrasonic wave for you to understand ultrasonic testing very well. Okay, and then Professor Guy Fiat will give a generation detection of ultrasonic wave, focusing on piezoelectric ultrasonic transducer. After that, student will tackle a project work. This is day 2. Then day 3. So lecture start from 10:30. Again, Professor Guy Fiat will give a lecture on application of ultrasound to medical and material industrial application. Then Professor Nicolas Murray will give a detailed lecture on material degradation and mitigation strategy to mitigation strategy for material degradation. Then we close the seminar or the lecture. Then we will have a presentation session by a student for joining intensive course. That's all. That is old outline of all these 3 days lecture. Okay. On this occasion, I also want to introduce a risk-based maintenance very briefly at the beginning of this 3 days lecture. But in order to understand risk-based maintenance, we would like you to know what is safety. So do you know what is safety? Maybe many of you understand what safety. But if you ask to explain what is safety, maybe it is difficult, right? Example, what is safety? Yeah.
I would say the measures and things we do in order to prevent danger or harm to the user or its environment.
Perfect. Okay. Okay. Yeah. And what is safety? So if we consult with a dictionary, so Oxford Dictionary say safety is a condition of being safe. It is not so clear, but freedom from danger or risk, as you mentioned. Okay? This is a safety. But it's interesting. In the field of engineering, safety is clearly defined. And there is a standard, ISO IEC Guide 51. This is a guideline for the inclusion of safety concept in standard. So in each country, they have we have a standard. For standard, safety concept is very important. But if the safety concept is different among the country, that is not so good. So to unify the concept of safety, so ISO IEC guideline define the safety. So this guideline say safety is freedom from risk which is not tolerable. Even this case, this statement, it is not so clear. But in order to understand this, so you should understand what is risk. Okay, and in this guideline, risk is defined very clearly. But before explanation of risk, I would like you to know hazard and risk, the difference between the hazard and risk. Okay, so hazard is a potential source of harm, like fire, heat, water, and so on. As you know, people are killed by fire or by flood, water. Many, sometimes we have some victims. These are potential source of harm. We call this a hazard. But if there exists a hazard, it is not directly dangerous. So looking at this picture, so there is a child and a fire. So fire is dangerous for the child. But if we make a barrier correctly, so we can avoid dangerous state by this barrier. And the risk, as I explained, it's related to a dangerous condition. And risk is decided by the balance between the hazard potential source and a protection or a barrier. So we can manage risk by the barrier. Next, so how risk is evaluated? So there are some way, but this is a method to evaluate risk in the in specified in ISO IEC guideline. So risk is featured by probability of occurrence and scale of resulting harm. Okay, and visualized in this graph consisting of two axes. Of course, if the harm is serious and the probability is so high, in this case, of course, you cannot accept. And this is intolerable risk. Okay, but if the probability and the resulting harm is low enough, this is acceptable. Okay, so we evaluate each event, a risk of each event by probability and the scale of harm in this diagram. Okay, and usually probability and harm is expressed in log scale. So this line is a equi-risk line. This line corresponds to risk line, but usually harm is emphasized, and the equi-risk line should be shifted this way because the importance of harm is larger than probability. Okay, so how the concept of risk is applied to maintenance activity. So there is a maintenance activity, risk-based maintenance activity method to apply the concept of risk and optimize maintenance work. Of course, as I mentioned, maintenance work includes inspection or evaluation of or repair. In order to do so, it needs cost, as you know. So, but the cost that can be used for maintenance activity sometimes limited. So we should allocate maintenance resources very correctly. And when we allocate the maintenance activity, risk can be a good measure to allocate. Okay, and if we think about the risk of maintenance of plant, as you can know, that the plant has a lot of components like many piping or many generator and so on. So there are many components, and we should make a maintenance activity of enormous amount of component. And in risk-based maintenance, we evaluate the risk of each component. So for each component, we evaluate probability of failure. Okay, and also for each component, we evaluate consequence. Consequence is a resulting harm or loss. Sometimes people are killed or killed. This is a consequence. Okay. So this is one example of evaluating, assessing a consequence of failure. So from level 1, this is the most serious one. In this case, we will get some fatalities, or we got a direct cost. enormous direct cost. Or if we think about the chemical plant, chemical impact by chemical impact, some fatality we got, or environmental impact that is evaluated by cost. And also other aspect of evaluating consequence is report by media. If national media post this accident, this is very serious one. But for a minor one, just local media cover this accident. Or a light one, no coverage. Okay, in that way, we can evaluate consequence. And also, likelihood of failure. So probability of failure by failure of a component. So we can evaluate probability of failure like this per year, like this. Or sometimes we can evaluate by mean time between failure. It's something like average time between the accident. Okay. So in that way, for each component, we characterize risk. And of course, if the component, risk of some component lie this region, this is not acceptable. In this case, we need to put maintenance resources. Then risk will be reduced, both for consequence and the likelihood of failure. Okay. But even if we do a lot of maintenance work, this is important. Risk cannot be zero. We cannot eliminate risk. Okay? So there remain some amount of risk. We cannot eliminate. And this risk we call residual risk. Please understand that risk cannot be zero. Okay, and but we should manage this residual risk. There are two ways. So give up risk. This is risk retention. So we keep the responsibility of risk, or risk transfer. This means that we transfer the responsibility of risk to other organizations. So this, for one of the good example is insurance. Okay, insurance is one of the representative way to risk for the risk transfer. Okay, and if for example, inspection, I introduce inspection or evaluation repair as a measure of maintenance activity. How this activity contribute the reduction of risk? Actually, degradation science and inspection or repairs technology should contribute decrease the probability of failure. Because if we do inspection, there is a possibility to find a small failure before the big accident. And if we have a good degradation science, so we can predict the behavior of material consisting the component. In that way, we can avoid component failure. So in that way, we can decrease the probability of component failure. Okay, so in this course, I hope all of you understand how to contribute to decrease the probability of failure by inspection or degradation science. Okay, so this is the so all of my introduction